B22。加州大学以 Let There Be Light 作为他们的校训，希望学生把家中灿烂、令人印象深刻的阳光普照大地。沐浴在加州阳光下的小组成员们，相信在美国这18天的经历，将会在不同方面对他们的未来有所启发，成为他们生命中的光。让我们欢迎 B22 Light。Greetings,
everyone. I'm Tu Hao from Wuling Senior High. So the overall process of our presentation today are as follows. So first we'll introduce the first topic, game development with C++. Lu Guanting will explain what we have learned from the camp about C++ and its syntax, and I will explain and demonstrate my game project. And the second part will be reinforcement learning. This subtopic of artificial intelligence will be introduced by Chen Zuiyan and Chen Jinzhong. They will show you the mechanism behind it and its application. And finally, we'll have Li Jingwei to share what we have learned from the camp and our lives in the States. So firstly, let's welcome Lu Guanting to explain what we have learned about C++.
Okay, I'm Lu Guanting. Let's start with C++. And first we learn C++ with ID Gameplay, which is a website look like this. And there are many courses here and below. We can learn these courses by ourselves. In 5-day class, as we had known about C++ to some degree, so we quickly passed some basic syntax like loops and operators or variables. And we spent about 3 days on learning data structure, like we learned how to build up array, vector, pointer, and classes. And we use this to build out to construct the basis of a program. Among this, I think pointer is kind of difficult for me as it's not only complex but abstract. Simply put, it's like variables addressed in the memory. I think the most impressive and meaningful part for me is that we learn how to develop a game by ourselves. We developed a game by SFMLO. We also call it simple and fast multimedia libraries as a huge library containing many useful functions. So let me illustrate what function we have learned. First, we learned how to draw the shape. For example, we draw the pumpkin face for practice. Then we know how to show sprites on our games. Also, we can control the sprite that it does some animation or movement. Last, we also learned how to dictate whether two object or sprite is collided. Above all is what we use to make up again, and later Tuotto will make a deeper explanation by his.
So after we obtain all these skills, we can build up my game. So my game is basically a shooting game. You can see here's the player and enemies is being spawned. And after they are all ready, the enemy will start moving and shooting bullets to the player and the enemies. They will shoot bullets to each other. So that's, let me introduce the components of the game. So the first component of the game is the player. So the player in the game is basically a geometry sprite. But if it's just a simple plain image, it will be too boring. So I set it to face the position of the mouse. So how do I implement that in C++? So let's say you have your player over here, and your mouse is the cute little face over here. So this way, we can calculate the horizontal and vertical difference from the player to the mouse position of your mouse. And we calculate the angle we need for the rotation by using tangent. So this can also be applied to any kinds of position, such as this one. So the results are shown at this one. It follows the position of the mouse. So the next step for our player is to make it shoot bullets. So the next step is shoot bullets. So what's the behavior of a bullet? A bullet moves from the shooter to its target. So from the shooter to its target, and it flies to any direction at the same speed. However, the situation is that the distance between the player and the mouse isn't always the same. So how do we keep the speed at the same velocity? So that's demonstrated. Do some calculations again. Let's say players over here, the target's over there, and we can calculate the horizontal and vertical distance again. and we can get a vector, the white vector, from the player to the target over there. However, we want the bullet to shoot at the speed we want, the smaller red arrow. So we rescale the white vector by dividing it with the length of it. So yeah, so after rescaling, it will become the unit vector, and we times it with the velocity we want. So after that, it will fly. This is the implementation in C++. So after that, it can shoot at any direction at the same speed. So yeah, that's the implementation about the bullet. So the final component is the enemy. So I set the characteristics of the enemy, so it always faces the direction, the position of the player. And the next characteristic will be that they move to random points and they shoot bullets to the player. So yeah, so that's also about the concept of object-oriented programming. So I don't need to rewrite the code for building up every single enemies. Instead, I reuse the class I built before and build up all the enemies and bullets I need. So yeah, so I use a vector to store all the classes I mentioned before. And about the algorithm used in the game, I use the built-in intersection function to check if two objects like bullets and the player collides with each other. So the feature for the future is like I can set up a shield protecting the player so it wouldn't be hit by the enemies, or I can set up different difficulties levels for the game, or even build up smarter enemies with a prediction of the player. So maybe it can have some combination with deep learning. So yeah, that's the game development I have built after the camp. Thank you for listening, and let's welcome Chen Ruiyan.
Hi, I'm Jake Chen from Fudan Senior High School, and now my partner Bill and I are going to talk about reinforcement learning that we learned in the ID Tech camp. Yeah. And first, I'm going to talk about an application of RL, and you will have a common concept of it. Okay, it's called AlphaZero, and it's an AI chess player developed by DeepMind, and it's very powerful, and it has beaten many opponents, including the human one and another AI one in many compositions. And as long as human beings just tell it the rules of each games, and AlphaZero will learn how to play it and develop different kinds of strategies to win the game. And it trains by just playing a lot of games to learn experiences with itself. And that is to say that human beings didn't need to throw in a lot of manpower into AlphaZero. And why? Actually, it's just because of reinforcement learning, which is our topic today. And now, let me just give you some briefly introduction of reinforcement learning. It's a kind of machine learning which means to let a machine learn by itself. But what RL can do more is that it just can try to detect the states in the environment and make a guess and expectation to the outcome. And finally, will receive the best performance of each training and try to get used to it. Yeah. And you will think that it's actually just similar to the concept of trial and error as in psychology, but the trial and error that animals did is just like this way, but the AI can do the trial error very, very, very excellent as AlphaZero did. Okay, and I'm going to tell you about the essence of reinforcement learning. Actually, it's about to make a balance between exploitation and exploration. And it's just like the machine will try to adopt the efficient methods, efficient movements that have been found by the machine, and also try to explore something that haven't been discovered yet. And I believe that you guys have some basic information about reinforcement learning. And now we'll have Bill to tell us more details, and he will try to introduce our final project in ID Tech Camp.
Thanks, Jake, for giving us a general concept of reinforcement learning. And here, I'm going to show you my project, Carpool, and tell you more about RL in detail. And Carpool is basically a game that we aim to balance the pole on the cart and try to get the most points. But we don't play the game ourselves, but we'll train an agent to play for us. And this is how the agent will play the game. And first, we'll establish the environment for our agent to play. And the agent will first observe the environment and receive a state. And then the state will serve as the input of our fully connected neural network, which we have designed for our agent. And then through a bunch of hidden layers here, our neural network will output the possibilities of the available actions that our agent might take later. And later, our agent will take an action accordingly. And then the action will alter the state. And also, our agent will receive some rewards. And this loop will keep going on until the game is ended. But how? How do we train our agent to select a sequence of actions that really leads to the maximized rewards? And in RL, our only indicator of our agent's success is the rewards, which can be kind of sporadic. So who is to say that the action the agent just took was responsible for the rewards which the agent received? So here comes the policy gradient algorithm. And in this algorithm, we'll record each action, observation, and rewards. And after the game ended, the algorithm will test which actions led to the reward and which resulted in the failure. And we'll adjust the neural network to make the successful actions more likely and the other actions less likely. And for the purpose of that, we'll calculate the loss between the weights and the actions, and we'll multiply the rewards. And then based on the loss, we'll gain some gradients which we could apply to update our neural network. And after we apply them to our optimizer, we'll test our agent to evaluate our result. And in my case, it was kind of successful. But we also found some problems and difficulties. So let's welcome Jake again to talk about them.
Thank you, Bill. And now I'm going to talk about the difficulties in reinforcement learning and some problems that we met in our final project. Okay, the reinforcement learning it seems to be a very useful and very perfect for everybody to learn because its final performance is actually very great, as everybody just think. But actually, it's very difficult, and its difficulties is just more than we just expect. And as Bill just mentioned, in every project, in an RL project, we need to build a reward function, and it is also needed in every single project. Yeah, and that's actually the problem is. I mean, a reward function is very, very, very hard to design because we have to do many calculations with the states that detect in the environment. And also, it actually doesn't suit every environment because once we have finished a RL project, it doesn't mean that it's perfect enough. So we have to make a lot of adjustment to it. And the process of it just caused a lot of troubles. Yeah, and but luckily we didn't meet this problem in our project just because our states of the project is actually very simple and not very complicated to do calculation with. But there's still some problem that we met. It's that our final performance isn't always the same in each training. Actually, it should be the same, but it isn't. And we thought that the problem may be the reward function is not complete enough. So that's the thing that we still need to make an effort to improve this project. Yeah, and last but not least, I want to tell that reward function, RL seems really powerful, and because there's a few successful and famous examples of RL project, but actually each of them are very difficult to design, and there are only a few, really. There are not many, so many people will want to try this project and want to dig in this field, but RL is not always the best way to different kinds of solutions. I mean, if we only care about the final performance, we can just find another simple way and which has the same efficiency as RL did. But I think RL is a really challenging and mysterious things that I really want to dig in after the IT Tech camp. So I think I will keep learning something about that. Yeah, and that's all about our presentation of reinforcement learning. And now we'll have Joy to introduce the American life and things that we learned during the 18-day journey.
Hi guys, this is Joy Lee from Fudan Senior High School, and before I start, I would like to say thank you guys to be here so much. And I saw like some of you look like very tired. I totally understand this sounds like alien language to most of us, but the following 3 minutes should sound like, I don't know, English. All right. So, because our topic is light, so I got like 5 keywords starting with LIGHNT as 5 different aspects about our life and how things were in the States. So let's start. All right, L for life. All right, so for the 2 weeks, we're basically, every single one of us, we're paying a lot of attention at what we're learning, but mostly we spend like 70% of brain thinking about how to gain more of these stuff. We're basically like fighting each other to get this stuff, because these are tickets that could increase your chance of winning like souvenirs from Berkeley and Stanford, and most importantly, you get a chance to dunk or pie your instructors. That's definitely the part everyone wants. And then we have, this is basically the time schedule of Stanford, and that's pretty much the same in Berkeley. And I want you guys to see up here. Our class starts at 9 a.m. and ends around like 4 p.m. And I'm from a private school. My life is usually like the opposite. I go to school at around 4 something, and then I go home like around 9. So yeah, that's definitely a vacation for me. And most importantly, we have a lot of like lunchtime and a lot of activities, which we usually have like board games and a lot of soccer and soccer and soccer and soccer. So yeah, and then next slide. Yeah, I'll go deep a little bit into the food. This is what food was like in Berkeley. For my first week, I was like, all right, that's acceptable. But then I went to Stanford. They taught me what food is. So I totally shout out to everyone who went to Stanford first and then went to Berkeley. I have no idea how they survived. All right, so yeah. And then I for interactions in 2 different schools. So like I went to Berkeley first, and this is pretty much our classroom. Like there's only like 6 tables, and the whole ID Tech has around only like some lower than 100 person, and so yeah, we have a lot of chance to interact with our instructors more, because like we ID Tech in Taoyuan basically take a half of the place. But in Stanford, it's a lot bigger, and we have around like 200 students, so we have more chance to interact with international students. And then for G, it's a glamour. I'll show you really quick about how these schools looks like, because I don't have a lot of time. So this is basically Berkeley, and this is Stanford. A lot better, I know. But all right, so H, and then for highlights, this is definitely the point I want you guys to know. So we had a lot of drills when we first arrived to Berkeley, and the favorite part I love the most is the zombie drill. Everyone has to pretend that zombies are coming to Berkeley and shut down all the lights and stay under your bed. And then for Stanford, I want to tell you something. This is what my alarm looks like when I was in Taiwan, and this is when it goes off. Sometimes that doesn't wake me up. It's totally reasonable, right? But in Stanford, they make sure they wake you up, and this is how their alarm was like. And I want you guys to cover your ears up. You'll definitely need this. This is their alarm. This was 6:30 a.m. All right. Yeah, that's definitely not the alarm. It's what the fire alarm that accidentally went off. But okay, I have no time. I gotta skip through. And this was our weekend trips. A lot of places. All right. Then I want to go back to the reason why I want to name this light, because despite all the things we've learned about artificial intelligence, all those stuff, and these weeks, I think the most important thing is that we get to challenge ourselves, and the will and the nerve to challenge ourselves will definitely be lights that could light up totally different possibilities, of different aspects, of different dimensions, of different possibilities in our lives. So, and last but not least, I would say, let there be light, as what UC Berkeley said, and I want to say to you guys, as you guys are definitely the light of mine. Thank you.